So this is how to find the critical region for a Z hypothesis test. Notice that doing the same thing for a T test is not on the syllabus. So they of course tell us the standard deviation of the population, so we know we're in the Z world. A claim is made against the population mean. Somebody is saying it's more than 53. So we say the null hypothesis is that it is 53. Show me the evidence that it's more than that. So to find the evidence, we take a sample of size 60. And then if this sample contains enough evidence, we will reject the null hypothesis. And what does that mean? Well, here is all of the possible samples. The top 5%, the most extreme 5%, would convince us to reject the null hypothesis. So this region is called the critical region. And it is a one-tailed test because of this sign here, and which is based on the claim being made. We'll talk about a two-tailed test in a second. So this little region here is 5%. So this is just an inverse normal question. The only thing you have to ask yourself is, what is the distribution here? So you should know this. Tell me what the distribution is. I'm listening. Yes, you're right, because it is the central limit theorem. We're talking about the sample mean here. All the possible samples of size 60 you could possibly take from this distribution are in this diagram. And this is their distribution. We would expect them to have an average of 53 because we always assume the null hypothesis is true. And we know what their variance is because this is the central limit theorem. The central limit theorem is valid because the sample size is big. And so this is all totally fine. All I need to do is an inverse normal. Distributions, normal, inverse normal. So I want the tail to be to the right. I've always got a diagram in mind. I want the area of that tail to be 5%. What is the standard deviation? That is the square root of that number, which I'm going to write as 5 divided by the square root of 60. And what is the mean? 53. You can't draw it, so we just press enter. And that doesn't make any sense because I have put 0.5 in, 0.05, 54.1. So 54.1 is this line here. That's called the critical value. And the critical region is bigger than or equal to 54.1. Simple as that. Let's just adjust the question to a claim is made that the heights are not 53 rather than greater than 53. Everything else is the same. So I just change the null hypothesis to not equals to. And that makes it a two-tailed test. And the diagram looks like this. This time I've shaded the acceptance region just for a change. And the most extreme 5% are going to cause us to reject the null hypothesis. It's just that this time the most extreme 5% is split into two critical regions, 2.5% here and 2.5% here. And so it's a very similar question. Let's just use the calculator because we know the distribution. Distributions, normal, inverse normal. And this time I'm trying to do this diagram. So I'm going to put a central region in. And rather than 5% then, the area I'm after is 95%. The standard deviation is the square root of 5 squared over 60. The mean is 53, press enter. And it gives me two numbers that are the two critical values. 51.7 to 54.2, and we can answer all questions like the critical values are those, the critical region is bigger than 54.3 and or less than 51.7, the acceptance region is 51.7 up to 54.3. That's it. So easy.